So we've talked about functions in the last unit, and we discussed the idea that functions are relations. Just as a quick reminder, function is a relation, which is a group of ordered pairs, where the domain is related to only one range. In other words, the x does not, or the x's do not, the x does not go to more than one y. So, for example, if we had a group of ordered pairs and we had 2, 5, 7, 8 as the domain, and -1, -3, -5, and -7 as the range, this is a relation because the 2, the 5, the 7, and the 8 only go to one specific variable or one specific value of y. Even if I was to change a y value and make it the same and the y repeats, it is still a function. However, if the x repeated itself, so let's say that this was a 2, and the 2 goes to the -1 and the 2 goes to the 7, this would not be a function. The other way of testing for functionality is to look at a graph. For example, if I had something that graphed to look like this, it would be considered a function because of the vertical line test. It only goes through one point at a time. The other way would have been not a function if it was sideways. It would not be a function because it goes through 2, because that means that the x is repeating. So with that, if we are looking to see if things are linear functions, then what we're looking to confirm, as we discussed in last unit, is if the function creates a straight line. And a linear function is always going to be able to be written in the form of y equals mx plus b, where x is the independent variable, m and b are numbers. They're real numbers. In other words, they're digits. It's not any imaginary number. They're numbers, -1, 1/4, a third, -0.7. All of those would be considered real numbers. The m is symbolic for slope, and the b is the y-intercept. So we covered this a little bit last year. Remember that a y-intercept is the point at which the line crosses the y-axis, and the slope is considered the rise over run, which we'll go into a little bit more detail later. It's how steep the line is. A linear equation is the same thing. It's like a linear function. The difference is that instead of having f of x, it is written in standard form. So a linear function is a function that would be y equals mx plus b, where instead of writing y equals, you could just write f of x equals, or y equals. Remember, it means the same thing, but you'll often see it with f parentheses x, which means function of x. A linear equation is written with the y equals. So the difference between the two, equations don't have the function notation such as linear functions do. It's an equation that can be written in the standard form of a line. So here we have two special words that you need to make sure you understand. This is slope-intercept form, and standard form is ax plus by is equal to c. And that just basically means that this equation, or this function, this equation, if you move, this is a value. If you move the y and the mx together, then you would have it in this format. So let's look at this example. Identify which ones represent functions. So they're first asking if it's a function and why. And if it's a function, is it linear? So we look at the first one. Well, the first one is a function. First of all, because it's a straight line, so therefore it is a function. So it is a function because only one point is crossed by a vertical line, or you could just say because of the vertical line test. So that's probably shorter. You could just say vertical line test, and it's linear. The next one is also, if we put a vertical line through it, it is also a function, and it is also linear. The next one, well, it's linear because it's a straight line, but when I put a vertical line through it, it goes through an infinite number of points, so it is not a function. As we look through the next couple, this one is also not a function because the vertical line goes through more than one point at a time. And this one is a function because of the vertical line going through only one point at a time. And again, the reason to why the vertical line works is the domain is not repeating. That's the reason why. Make sure that you understand that. If we go back and look at letter C, if I had a straight line go through two different points, those 2 points right there, if we were to look at the value of the coordinate, it's 1, -1, and the other one is 1, 1. Notice that the domain is repeating, going to different ranges. Vertical lines always do that to each other. They go through the same value of x. The next group of questions are asking us whether something is linear or nonlinear. So as we look at the relations, the group of ordered pairs, we want to know if it is linear. In order for it to be linear, and this is the key, think about the fact that the points, they are going to be spaced apart in an equal manner. They're going to be consistent. There must be a constant rate of change for a function to be considered linear. And what does a constant rate of change mean? It means the following. It means that when you have a relation, and if we look at this relation here, the change, and remember this Greek letter, delta, represents the word change. The change of y over the change of x, this here is a fraction. It's telling you that as y changes consistently in this manner, x changes in this manner. So for it to be linear, the constant rate of change has to be present. And this rate of change is the change of y over change of x. This has to be consistently through the relation. If this is true, then the whole thing is a function. So let me show you, because maybe all those words are kind of confusing right now. So in this case, if we look at the first question, the change of y, we're looking at our y values. From this y to this y, we changed -4. From 16 to 12, -4. 12 to 8, -4. So the change of y was -4. The change of x is going up by 5. This is called a linear function because the rate of change is constantly -4 over 5 throughout the whole relation. If we look at the nonlinear function here on the right, you're going to notice that change of y is 2, but from here to here it's 6. And when you do 2 over the change of y over the change of x, remember, change of y is 2, change of x was 2, that gives you 1. So the rate of change from the first step, the first point to the next point, was 1. Then the next, if I was to go to the second point, from 2 to 8, that change of y was +6. The change of y was 6, and from here to here, the change of y was positive 2. That change of y over change of x gives me 3. So the rate of change from that point was 3. It's immediately not a function because it's not the same rate of change. So as long as the rate of change is consistent throughout, it is a linear function. So let's look to see. Number 2, letter A. Tell whether each set of ordered pairs satisfies a linear function and then explain. So the first thing we're going to remember is that in order for something to be linear, the change of y over the change of x has to be consistent. So it's always good to organize it visually to help us see a little bit better. So I'm going to write this as a table. So we're going to write all of our domain values, 2, 5, 8, and 11. And then our y values, if you look there, are 4, 3, 2, and 1. So again, what I've done is I just listed all my x's, 2, 5, 8, 11, then 4, 3, 2, and 1. We're going to calculate the change of y over change of x. Here, we went down by 1, and here we went up by 3. So the first change of y over change of x was negative 1 over 3. The next one, down by 1, up by 3. Down by 1, up by 3. Yes, this is a linear function because there's a constant rate of change. Next one, x values, y values. So it's negative 10 and 10, negative 5 and 4, 0, 2, 5, and 0. Change of y, add 6. Change of x, add 5. Next one, from 4 to 2, add 2. Oh, add 5. Well, 2 over 5 is not the same as 6 over 5. If we notice this change of y over change of x is 6/5. This one is 2/5. Let's just go to the last one just in case. Up from 2 to 0, you went down 2. And from 0 to 5, you went plus 5. So this one was negative 2 over 5. So this is not linear because no constant or not constant rate of change. As you will see once we move forward into the rest of this unit, constant rate of change is the same as slope. When you see the word constant rate of change or when you see the word slope, they mean exactly the same thing. Sort of like function and equation mean the same thing, constant rate of change and slope mean the same thing. All right. Tell whether each function is linear. If so, graph the function. Well, hopefully at this point you look at this and you go y equals x plus 3. Oh, if I had y equals mx plus b, the m is really 1. So yes, it's function and it's linear. It's a linear function because it's in the form, in slope-intercept form, y equals mx plus b. I go ahead and graph it, and you can do this one of two ways. You can either remember that the b is the y-intercept. That means that's where the line crosses the y-axis. Well, the b, y equals mx plus b, if I write it right underneath it, the b is positive 3. That means that at positive 3, I cross my y-axis. If you recall, the m, the value of m, is the slope. And in this case, the m is 1. If the slope is 1, and slope is rise over run, or change of y over change of x, 1 written as a fraction is 1 over 1. That means you go up 1 unit to the right 1 unit from your y-intercept. And in that case, it would go up 1 to the right 1. So that is the next point that I would put. Oh, these are little markings that are throwing me off. Up 1 goes up to 4. To the right 1 is right here. So 1 comma 4 is the next point. And really, that's all I needed. Now I just extend the line, and that's the equation of the line. That is the function y equals x plus 3 graphed if I wanted to graph it. The other way of doing it would be to make a table of values. If you are asked to make a table of values, what you must remember to do is, just like we did with our function table in the last unit, you put in any value for x. You can always do -2, -1, 0, 1, and 2, because those are good numbers to just plug in, so it gives you a good range with a domain of how wide it's going to open up to be. And remember, I always say, when you are plugging values in, rewrite the original equation with parentheses instead of the variable that you're plugging in, so that all you have to do is plug it into the parentheses and you don't lose any negatives, as you all have experienced a couple of times. Plug in -2, plug in -1, 0, 1, and 2. -2 plus 3 is 1. So -2 comma 1 is the first point. -1 plus 3 is 2. So -1 comma 2. 0 plus 3 is 3. 0 comma 3. 1 plus 3 is 4. 1 comma 4. And 2 plus 3 is 5. So 1 comma 5. If we plot those points, you're going to notice that all of those points are going to be on that blue line. So you could have either done it as y equals mx plus b, if you're comfortable with that already, or you could do a table of values. Either or works, because they're both graphing the same line. So when I go to plug those points and actually plot them, -2 comma 1 is right here. -1 comma 2, 0 comma 3, notice it's the y-intercept, 1 comma 4, and 1 comma 5. I'm sorry, not 1 comma 5, 2 comma 5. I made that mistake. 2 comma 5. All of those points are on the same line because that line is the same line that I graphed. Y equals x plus 3. All right, next graph. They'd like for me to graph y equals x squared. Well, just by looking at this, hopefully you remember our little saying, power of 2 makes a u. And if it's a u as a graph, it's a function, but it's not linear. So you already know it's not linear. If you forgot power of 2 makes a u, you would still create a table of values like we've been taught to do whenever we're graphing. Plug in your values of x, remembering that we always want to see the big picture, so we pick positives, 0, and negatives. We're going to find the value of y, and we're going to rewrite it with parentheses because we want to make sure that when we plug things in, we are not going to lose negatives. Rewrite with parentheses. This part that I'm doing may seem a little weird and repetitive, but it will absolutely ensure that you do not make mistakes with negatives. Now, when I go to plug this in, I'm plugging the entire -2 into my parentheses. I am squaring -2, the whole -2. So this is really -2 squared, which is positive 4. So my first point is -2 comma 4. Plug in -1. -1 squared is 1. Next point, -1 comma 1. Plug in 0. 0 squared is 0. 0 comma 0. Plug in 1. 1 squared is 1. 1 comma 1. Plug in 2. 2 squared is 4. So 2, 4. Plot those points. -2, 4 is right here. -1, 1, 0, 0, 1, 1, and 2, 4. Now, at this point, you may think it's a V just because it looks like a V, but you must remember that power of 2 makes a U, so when you graph it, it's your responsibility to curve that bottom part so it does not look like a V. Because if it looks like a V, it's absolute value inequality, absolute value equation or function. So this is not linear. It is a function, but it's not a linear function. Word problems. Oh no. Remember, whenever you see a word problem, just give yourself the benefit of the fact that it's okay to get freaked out by them because that's part of the whole brain process. You see words, you're in math, you get confused. Read it for a story first. At another salon, Sue can rent a station for $10 a day plus 3 per manicure. The amount she would pay each day is given by the function of x equals 3x plus 10. So they're giving me the equation. They're not even asking me to write it. Where x is the number of manicures. So I'm just going to write that down. X is number of manicures. Graph the function and give its domain and range. Okay, so first of all, I know that the x is always independent. So I am going to write down manicures down here, number of manicures. And that y, well, $3 per manicure. If I have my equation f of x is equal to 3x plus 10, that's the same thing as y equals 3x plus 10, where the y is the amount of money that she has to pay to rent the station. So we're going to put rental payments on the y-axis. In dollars. They want us to graph this. Well, it's the same exact type of function process. We know f of x is equal to 3x plus 10. You could write y equals if it makes you feel better. Let's go ahead and do that just to show you that it's the same thing. And we are going to put in values. When we put values in here, we're not going to put any negative values because you can't have negative number of manicures, right? If we know that this is the number of manicures, we're not going to have negative. So you could either have 0 manicures, 1 manicure, 2, 3, 4, 5, let's say. We're going to plug it in. The y is going to equal 3 times x plus 10. And again, we're going to just rewrite all of the equations so that I remember to plug things in properly. Now at this point, we plug in all our values. 0 plus 10 is 10, so 0, 10 is 1 point. 1 times 3 is 3 plus 10 is 13. 3 times 2 is 6 plus 10 is 16. 9 plus 10 is 19. 12 plus 10, 22. 15 plus 10 is 25. Now I have my points, and I'm going to graph the points. I went up to 5 manicures, so I'm going to go 1, 2, 3, 4, 5. And payments, the highest number is 25. So I'm going to count by 2s. Let's start with 10, because 10, 12, 14, 16, 18, 20, 22, 24, and 26. And now I just graph my points. First point, 0, 10. Second point is 1, 13, which is right about here. 2, 16. 3, 19. 422, and 525. Connect the dots. Straight line with an arrowhead at the end so that we know that it goes continuously. It keeps on increasing, if you notice, because I could have had a 6 and a 7 and an 8 and a 9, etc. It's going on forever. So that right there is how to graph it. Now, the other question, remember, make sure you answer the entire question. Give its domain and range. Remember how to write that. The domain included all of the whole numbers, right? 0, 1, 2, 3, 4, 5. You don't have any fractions in between. So you can't use an inequality that says x is greater than 0 because then that, or greater than or equal to 0, because then that would be implying that you have values between the whole numbers. You want to make sure that you're describing only the whole numbers. So you're going to write it as 0, 1, 2, 3, 4, 5, dot, 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 instead of x is greater than 0. The range, similarly, the least number is 10, the greatest number is 25. And then it goes on in a specific pattern because there's a constant rate of change. So you're going to write $10, 13, 16, 19, 22, 25, dot, dot, dot. Now, if you can remember, this here is an arithmetic sequence. It's an arithmetic sequence where there's a pattern. It's going up by 3, up by 3, up by 3, up by 3, up by 3. That right there, if you remember, was the common difference. And so we have to make sure that we write it as the sequence that it is with the dot, dot, dot. Don't just write it up to 25 because you could have had more values of x with subsequent more values of y. So make sure that you're writing it properly in the sequence form as well as in this proper format as well. Your assignment will be, if you please make sure that you have printed out or at least downloaded to Notability, the independent practice that is on the last page of the notes. Make sure you either print it and then take a picture and upload to Canvas, or download to Notability and then upload to Canvas when you are complete with these questions. It shouldn't take you that long. It's just 15, 20, 10 questions. That's all it is. And again, email me if you guys have any questions, and I will see you tomorrow.